Welcome to Math 104, Section 6.2, Adding and Subtracting Rational Expressions, Part 2. So last time, we worked on finding a common denominator and expressing rational expressions in terms of that common denominator. And now we're going to take the next step into actually adding and subtracting those rational expressions together. Please start with a warm-up. So the first one, we've got already have a common denominator. So all we have to do is go ahead and add straight across. 2 plus 3 is 5. And now the denominator stays the same. Now in math, it's really important to know why we're doing the things we're doing. So why does the denominator stay the same when adding or subtracting fractions? Well, the denominator represents what we are adding or subtracting. Right? We're adding or subtracting ninths. Now, if you add together 5 basketballs and 6 basketballs, you don't get 11 umbrellas, you get 11 basketballs. So the thing we're adding and subtracting doesn't change. If we have 2 ninths and 3 ninths, we get 5 ninths. The thing we're adding and subtracting has to stay the same. Now the numerator represents the number of those things. We have 2 ninths and we have 3 ninths. So we add them together, we have 5 ninths, 5 of those things. All right, now, second one, we do not have a common denominator. So we can't add these things together because this would be like adding together cars and basketballs. You can't add them together. But we can if we have a common denominator. So I'm going to write these using the prime factorizations that we learned last time. That way I can use the exact same techniques that we were applying to rational expressions to this problem. So I can rewrite 6 as 5 over 2 times 3. So there's the prime factorization of that one. And over here we have 3 over 2 to the third power. Right now, using the techniques that we learned before, if I want to find the least common multiple of those two denominators, I take the highest exponent for each base. So that'd be 2 to the third times 3, which is 24. All right, so our common denominator will be 24. So using the techniques of last time, let's turn these into fractions with a denominator of 24. Okay, so we're going to multiply by what is missing. In our common denominator, we have 2 to the third times 3. Here we have 2 times 3, so we're missing 2 2's. So we're going to have to multiply this by 2 squared over 2 squared, which is just 4 over 4. So you multiply the top by 4 and you get 20, and the bottom by 4 to get 24. So there's our common denominator. Plus, and then on this side, we're missing the 3. So we'll multiply this one by 3 over 3. So that gives us 9 over 24. And add them together. And we get 29 24ths. So kind of a convoluted way to do this one, but better practice for what we're going to see today. We're going to start by adding and subtracting rational expressions with the same denominator already. So first example, we got 7x over 11 plus y over 11. Adding those together, we'll add the top. We can't actually combine them because they are not like terms, so we'll just write that as 7x plus y over the common denominator of 11. Your turn, number 1. All right, so add the top, 2 plus 6x over 9. Now, we could factor out a 2 up top, but that won't help us because the bottom is even, so we wouldn't be able to use that to simplify, so we can just leave it like that. Now we always need to look to simplify the result. So next example, we've got 4x over 12 plus 5x over 12. All right, we do have like terms, so we can combine them, so that'll be 9x on top over 12. Now this can be simplified. 9 twelfths reduces to 3/4. So this would be 3x over 4. Your turn, number 2. 15x over 21 minus 6x over 21. We have like terms on top. We'll subtract those. And we get 9x over 21. All right, now we need to reduce this. Got a common factor of 3 on top and bottom, so you can divide by 3 and get 3x over 7. Now sometimes the either the numerator or denominator can be factored, so we always have to look for opportunities to factor and cancel. So we're going to combine these. We have our common denominator. Combine the top. Now I'm just going to switch the order. It doesn't, with addition, order doesn't matter. I'm going to write it as x plus 6 over x squared plus 3x minus 18. Now let's factor the denominator, see what happens. Two numbers multiply to get negative 18, add to get 3. That's going to be x plus 6, x minus 3. So we got a match, x plus 6, so we can cancel those, leaving 1 over x minus 3. Go turn number 3. So putting them together, we get x plus 5 over our common denominator. Now we can factor this. And we get x plus 5 times x minus 4. The x plus 5's cancel. And we get 1 over x minus 4. So just like we saw before, there are hints built right into these problems. They're all kind of set up the same way, so you get these nice cancellations. So if you factor the bottom and you don't get a match, that's a clue that something probably went wrong. All right, next example. Now we're going to need a little bit more sophisticated factoring to do this one. All right, so some students ask, why in the world do we need to memorize these factoring formulas? Well, it's very useful to have them in your memory so that when you encounter a problem like this, you can see the pieces of the factoring forms. So let's see how that shakes out with this problem. So we're going to subtract these. We have our common denominator, a to the third minus b to the third on top over a squared plus ab plus b squared. All right, now up top, we have difference of cubes. And the bottom, we have one piece of the factoring form of difference of cubes. Remember, we got the binomial times something that looks like that. So when we factor this, we're going to get a cancellation. So we'll factor a to the third minus b to the third. That factors into a minus b times a squared plus ab plus b squared over a squared plus ab plus b squared. All right, so we can cancel this part, cancel the trinomial, and we're left with just a minus b. Your turn, number 4. All right, so we got the other version here. Here we had difference of cubes, now we got sum of cubes. P to the third plus Q to the third. And here's the one piece of the factoring form of sum of cubes. I know, factor the top, so that factors into P plus Q times P squared minus PQ plus Q squared, which matches what we have here in the denominator. So now we can cancel those, and we just get P plus Q. Right, now we're going to start adding and subtracting rational expressions with different denominators. So we're going to do what we did yesterday. We're going to start by finding the least common denominator, which is the least common multiple of the denominator. And then we will transform each rational expression into ones having that common denominator, and then we'll combine them just like we have so far today. First example, 6 over m plus 1 over 4m. Alright, so we've got only one coefficient. So that means that's going to be the coefficient on the LCM. And then we've got one variable to the first power. So our LCM is just 4m. So the only one we need to transform is the one on the left. We need to multiply this by 4 over 4 because that's what it's missing. So that gives us 24 over 4m plus 1 over 4m. And we get 25 over 4m. Your turn, number 5. So basically the same situation here. Got an extra number over here, it's missing over here, so we're going to multiply the first fraction by 3 over 3. So we get 9 over 3x plus 13 over 3x, and that gives us 22 over 3x. Now in this case, we're going to need to transform both of these because we need to find the least common multiple of 2 and 3, which is 6. So that means the LCM equals 6a. Alright, to get a 6, this one's missing a 3, and this one's missing a 2. So we're going to multiply the first fraction by 3 over 3. And the second fraction by 2 over 2. And that'll give us the common denominator of 3a. So we got 18 over 6a plus 24 over 6a. Combine those and we got 42 over 6a. Now 42 and 6, they both have a common factor of 6. So we'll divide the top and bottom by 6 to get 7 over a. And that is the fully simplified result. Your turn, number 6. Alright, so we just have one variable, they're both to the first power, so we're all set there. We need to make sure we get the same coefficient out front. The least count multiple will be 12x. So we'll multiply the first fraction by 4 over 4, and the second fraction by 3 over 3. So that gives us 20 over 12x plus 6 over 12x. Or 26 over 12x. Now 26 and 12 have a common factor of 2, so we'll divide the top and bottom by 2 to get 13 over 6x. Let's look at some denominators with a few more variables in them. So to find the LCM here, we got 9 and 18. 18 is 2 times 9, so 18 is going to be the coefficient. And then we look at the variables. Take the largest exponent, so that is 8 to the third, b squared. So as it turns out, this fraction is already done. We don't need to change that one at all. We just need to convert this one to have this denominator. So this one will stay the same. And we'll multiply the second fraction. We need to multiply by 2 to get 18. We need to multiply by a squared to get up to 8 to the third. Oops, squared. And we need to multiply by b to make that b squared. Now when we finally combine them, we don't have like terms here, so we cannot combine the numerators. So leave it like that, and with a common denominator, 18, 8 to the third, b squared. Your turn, number 7. Yes, it won't always be the case that we get to simplify these. So we have the same situation here where the LCM is going to be the denominator of one of the fractions. All right, we can multiply 6 by 2 to get 12. And we can multiply x by x to get x squared. So we're going to multiply by 2x over 2x, and that will give us matching denominators. Now multiplying across here, we have 22x over 12x squared y. Combining, 5 minus 22x over 12x squared y. Now we're going to look at some binomials as denominators. All right, we have different binomials, and there's no common factors between them. So that means the only way we can get a common denominator is by using the product of the two. Well, it's not the only way we can get a common denominator. That's going to be the least common denominator. All right, so how do we get there? We're going to multiply this fraction by this fraction to the denominator over itself. X plus 1 over x plus 1. All right, we're multiplying by what's missing. We want to get here. We already have the x plus 4, so we need to multiply by x plus 1. And over here, we've got the x plus 1. We need the x plus 4. So we'll multiply this one by x plus 4 over x plus 4. All right, now, in order to combine up top, we're going to need to multiply all this out. We need to distribute here, and we need to FOIL here. So I'll distribute the 3 in. We get 3x plus 12 over x plus 4, x plus 1, plus, and on this side, we're going to FOIL. Looks like we have the factored form of difference of squares, x minus 1 times x plus 1. So if we just use the difference of squares formula, this turns into x squared minus 1. So just another example of how knowing your formulas is a time saver. We didn't have to FOIL and cancel, we just wrote down the answer. Okay, now we're going to combine. So adding cross up top, we got x squared plus 3x plus 11. Over our common denominator, x plus 4 times x plus 1. All right, that brings us to your turn number 8. So our least common multiple will be x plus 4 times x minus 7. So that means we need to multiply this one by x minus 7 over x minus 7. Oops. And we'll multiply this fraction by x plus 4 over x plus 4. Distributing 2x into x minus 7, that gives us 2x squared minus 14x. And over here, distribute 3x into x plus 4. So we get 3x squared plus 12x. Now we can combine 2x squared plus 3x squared. That gives us 5x squared. We got negative 14 plus 12x as minus 2x. And I should have noted in the last one that trinomial on top is prime, so it's not factorable, so we can't cancel there. Here we could factor out an x and get 5x minus 2, but that does not match any of the binomials on the bottom. So this is not simplifiable. We'll just leave it at that. All right, another example coming up about how flipping binomials is really handy. We got 2 over 4 minus x plus 5 over x minus 4. All right, so we got binomials with the terms in the opposite positions. So we can flip this binomial and make it negative. So we got 2 over negative. Actually, you know what I'm going to do? A negative can appear anywhere in the fraction. I'm just going to move it up top. Turn that into negative 2 over x minus 4. plus 5 over x minus 4. Remember, a negative can appear. It can appear here, but then we don't have common denominators. So we want to take that negative and either move it on top, or you can just move it out front. It all means the same thing. It doesn't matter where the negative appears as long as you have one negative somewhere. So I'm just going to put it up here. So that gives us negative 2 plus 5, which is 3. So we get 3 over x minus 4. Your turn, number 9. So here's a variable version of what we just saw, all variables. All right, so we can flip one of these. I'm going to go ahead and flip this one. If I flip this one, I'm going to get another negative in there. So I get w over w minus z minus negative z over w minus z. All right, so I flipped the bottom fraction and then made the top value negative. All right, now we are taking w minus negative z. That's the same as w plus z. So we get w plus z over w minus z. Now, in the next example, in order to find a common denominator, we're going to have to start by factoring. I'm going to factor both of these trinomials. X squared minus 5x plus 6 factors into x minus 2 times x minus 3. And we've got a perfect square trinomial. Factors into x minus 2 times x minus 2. Alright, so we have one match here. So I'm going to go ahead and write this as x minus 2 squared. Now, when we find the LCM, we'll just take the highest exponent. So we got LCM equals, alright, we got an x minus 3. We're going to keep that base. Make sure you keep all bases, no matter if they appear in one or both. And x minus 2 squared. So in our denominators, we need 2 x minus 2's and 1 x minus 3. Well, over here, we have the x minus 3, but we only have 1 x minus 2. So we have to multiply this fraction by x minus 2 over x minus 2. And over here, what we're missing, we have both x minus 2's, but we need an x minus 3. So multiply this side by x minus 3 over x minus 3. All right, distribute. 3 in here, we got 3x minus 6 over x minus 2 squared times x minus 3. And then over here, distribute in, we got 2x minus 6 over x minus 2 squared times x minus 3. Now we can combine the top. So 3x minus 2x is x. Negative 6 minus negative 6, that's 0. So that gives us x over x minus 2 squared times x minus 3. Your turn, number 10. We'll factor these. We've got a perfect square trinomial here, so that is x plus 3 squared. And on the right side, we can factor this into x plus 3 times x plus 1. So we have two bases. We have x plus 3 and x plus 1. Highest exponent of x plus 3 is 2. So there is our LCM. Alright, we have both of the x plus 3's on this side. We need the x plus 1. And on this side, we have the x plus 1 and one of the x plus 3's. We need one more. Now distribute 5 into x plus 1. That gives us 5x plus 5 over a common denominator of x plus 3 squared times x plus 1. And on the right hand side, we're going to distribute 2 into x plus 3, so that is 2x plus 6 over x plus 3 squared times x plus 1. Alright, now we're ready to combine. 5x minus 2x is 3x, and 5 minus 6 is negative 1. So we get 3x minus 1 over x plus 3 squared times x plus 1. So just like the last example, we're going to start by factoring. We've got a little trickier factoring problems here, multiple variate. And we're going to factor this one into plus minus. This factors into x minus y times x plus 2y. All right, we need two numbers to multiply to get negative 2 and add to get 1. So that's going to be negative 1 and 2. Now on this side, we need two numbers to multiply to get negative 6, add to get 5. So that will be x minus y times x plus 6y. So our LCD, our LCM, the denominators, we have x minus y, there's one base, we have x plus 2y, and we have x plus 6y. Alright, so there's going to be our common denominator. We need all three of those. Alright, so this one is missing, got those two, is missing x plus 6y. So we're going to multiply x plus 6y over x plus 6y times this fraction. So we have 5x, and I'm going to write it in factored form. X minus y, x plus 2y. And once you get here, just get rid of those original expressions. Always write the denominator in factored form. Minus. Okay, we got 3x over here. We've got x minus y. Oops. Y. X plus 6y. And we're going to multiply this one by the missing one. All right, we've got these two. We're missing x plus 2y. Now we can distribute. I'm going to distribute 5x into this expression. That gives us 5x squared. All right, 5x times x is 5x squared, plus 6 times 5 is 30, xy. Over our common denominator. And we use a little shorthand here. We know what the LCD is, as long as we, well, LCM, whatever. Okay, as long as you show what it is, you can use a little shorthand there. Prevents you from having to write the same thing over and over and over again. Okay, 3x times x is 3x squared. And then 3x times 2y is 6xy. All over our LCD. Now we can combine tops. So we got 5x squared minus 3x squared. That gives us 2x squared. And then 30xy minus 6xy is 24xy. Over. And we're not going to be able to simplify, I don't think. Let's see, we'll factor out a 2x, and that gives us x plus 12y. So no, we won't be able to simplify. So final answer, we should go ahead and write this out again. And we got x minus y times x plus 2y times x plus 6y. So just make sure, if you're going to use this shorthand, don't do it in the final answer. Final answer, write it out. That brings us to your turn, number 11. So we're going to factor these. All right, we're going to use the AC method here. 6 times negative 4 is a negative 24. So we need two numbers that multiply to get negative 24 and add to get 5. So that's going to be negative 8 and 3. And just to keep things a little cleaner, I'm just going to do the factoring off to the side. So that gives us 6x squared plus 8x plus 8xy minus 3xy minus 4y squared. All right, factoring by grouping. Got a 2x. That gives us 3x plus 4. 4y. 3x plus 4y. And then over here we can factor out negative 3y. Nope, not negative 3, just negative y. And that gives us, change the sign to positive, 3x plus 4y. And there's our matching binomials. And then that factors into 3x plus 4y times 2x minus y. All right, this is a little trickier, so I'm going to FOIL the check. 3x times 2x is 6x. Here we got plus 8xy minus 3xy, so that adds up to 5xy. And y times negative y is negative 4y, so that works. Alright, so this one is 6x over 3x plus 4y times 2x minus y. Alright, off to the right. This is difference of squares. So if we take the square root of 9x squared, we get 3x. Take the square root of this, we get 4y. So that gives us 3x plus 4y and 3x minus 4y. All right, now we need our common denominator. So we've got matching binomials here. The only ones that are different are 2x minus y and 3x minus 4y. So our LCM is 3x plus 4y times 3x minus 4y times 2x minus y. Now we're going to multiply by what is missing. This one is missing 3x minus 4y. And this fraction is missing. Got these two, we need 2x minus y. Now we can distribute. 6x times 3x is 18x squared. 6x times negative 4y is negative 24 xy over our LC. And you can say LCM, LCD, whatever. Okay, over here. 2x times 2y, that is 4xy minus 2y squared, negative y times 2y over our LCM. And now we can combine the tops. 18x squared. The only like terms we have are the xy terms. So it's negative 24 minus 4 is negative 28 xy. And we're subtracting a negative, so that turns into positive, so it's plus 2 y squared over 3x plus 4, 3x minus 4, and 2x minus y. And that is about as nasty as those get. So if you can do this one, you can do any of them. All right, next example. We're going to start by factoring. And so for this one, we're going to need one of these s's to be negative. And middle term is positive. So that one's going to be negative, and that one's going to be positive. All right, 3r times r is 3r squared. Here we got plus 3rs minus 1rs, so that gives us 2rs, and negative s times s is s squared. So that works. And this one will factor into, let's see here, we're going to do AC method. 6 times 1 is 6. Two numbers are multiplied to get 6, and add to get negative 5. Let's see. Here. 3r minus s and 2r minus s. All right, let's see if that works. 3r times 2r is 6r squared. We got negative 3rs and negative 2rs. I add together, you get negative 5rs, and negative s times negative s is positive s squared. So that works. All right, that makes our LCD. We got 3r minus s. 2r minus s and r plus s. So those are three unique binomials from the denominators. All right, so this one is missing 2r minus s. So we'll multiply this one, 2r minus s over 2r minus s times r plus s over 3r minus s times r plus s minus and this one has the 2 here, we're missing r plus s. All right. All right, now we got some foiling to do here. 2r minus s times r plus s. So first, 2r times r is 2r squared. We got 2r times s, that is 2rs. We got inside negative s times r, negative rs, and negative s squared. All over our LCM. This side, s times r, that's rs. Outside, s times s is s squared. Inside, negative r squared. And last, negative rs over our LCM. All right, now we've got some like terms we can combine. Here we have 2rs minus rs, that's 1rs. So this turns into 2r squared minus, or plus rs minus s squared over the LCM. Minus, and on this side, we have rs minus rs, those cancel. So we just have s squared minus r squared over the LCM. All right, so that simplifies a bit. Now we can combine the two fractions together. All right, we have 2r squared minus negative r squared, and that is 3r squared. Now I have rs, nothing to combine that with, so plus rs. And then we have negative s squared minus s squared, that's negative 2s squared. Now at this point, we have something on top. We have a trinomial. It looks like it's going to be factorable. So let's factor this thing. All right, we're going to use the AC method. 3 times negative 2 is negative 6. So we need two numbers that multiply to get negative 6 and add to get 1. And that is going to be 3 and negative 2. All right, so we break up that middle term into our two numbers, 3 and negative 2. So 3rs minus 2rs. Make sure you keep the same variable part in there. And now we can factor 3r out here to get r plus s. And over here we can factor out a negative 2s and get r plus s. So this factors into 3r minus 2s times r plus s. So what we have then is, I'll just write it here, put the LCD underneath here, so that gives 3r minus s times 2r minus s times r plus s. And we have a cancellation then. We can cancel the r plus s. All right, and what remains? We have 3r minus 2s over 3r minus s times 2r minus s. All right, last one. Your turn, number 12. So we'll start by factoring the denominators. All right, first one factors into y minus z times y plus 2z. All right, let's make sure that works. Y times y is y squared. Y times 2z is 2yz minus 1yz. That gives us the middle. And oop, it's supposed to be minus. Now it works. Okay, second one. Difference of squares. Y plus z times y minus z. So our LCM, we've got three binomials to include. We have y minus z, we have y plus z, and y plus 2z. So this one is missing the y plus 2z. So multiply this fraction by, no, that's in the way. Y plus 2z over y plus 2z. And this one, all right, we got the y plus 2z, we got the y minus z, we need y plus z over here. So y plus z over y plus z. Now we can distribute 3y times y, 3y squared. 3y times z is 3yz, all over our LCM. And on this side, we're going to FOIL the top, so 4y times y is 4y squared. All right, outsides, 4y times 2z, that's 8yz. Insides, negative 1 times y, that's minus y. And last, minus 2z, all over our LCM. Right, now we can combine like terms. 3y plus 4y, that is 7, or y squared, 7y squared. All right, now we can do the yz terms. 3yz plus 8yz, that's 11yz. We got a negative y and negative 2z. Nothing to combine with those. All over y plus z, y minus z, y plus 2z. And that is it. So these are some of the most challenging problems you're going to see in this entire course. So I urge you all to go and just keep working at them until you get them.